Today, industrial robotics has transformed the global manufacturing industry. Robots can perform repetitive tasks with greater precision and speed than human workers. Many traditionally dangerous roles, such as welding and die casting removal, has also been automated, removing the danger posed to human employees. This has led to increased productivity, improved quality, reduced cost, and reduced risk on injury for humans. However, let's go back in time and analyze the birth of robotics.
My next guest's most recent published work is his 221st book. I haven't written that many postcards. The book is entitled Enjoy Still Felt, an autobiography. Welcome, please, Dr. Isaac Asimov.
Who is the father of modern robotics? Who inspired the creation of these intelligent machines that now have an important and global presence in our world? That man would be Isaac Asimov. Born in Russia, Asimov was a writer and professor of biochemistry at Boston University. During his life, he was known as one of the biggest science fiction writers, having written and edited more than 500 books. In the 1950s, robots we are familiar with today were purely science fiction. In fact, Asimov was the first person to coin the term robot. He had many theories about the future of robotics in our world and how humans would interact with them. Asimov is often titled as the father of robotics due to how his insights into AI shaped our modern field of artificial intelligence. Asimov's book, I, Robot, explores problems that arise from ethical programming in AI, which he summarizes into 3 laws of robotics. The first law states, a robot may not injure a human being or through inaction allow a human being to come to harm. The second law states, a robot must obey orders given by human beings except where such would conflict with the first law. The third law states, a robot must protect its own existence as long as such protection does not conflict with the first or second law. The novel gives insight into the anxiety humans feel about AI and machines. In the book, we see robots employed to do heavy labor and tedious tasks, but humans are uneasy with their intelligence and question the effectiveness of the 3 laws. Near the end of the story, humans are almost entirely dependent on the robots, but still, they have a fear of their intelligence. Due to this, an amendment was made to the 3 laws, making a safeguard not just for human individuals, but humanity as a whole. This discomfort with robotics and their presence in our world can be seen today. Many worry robotics will take away jobs from humans, and AI will be a threat to our species. Some even suggest that we limit AI in a way that it cannot harm humans.
I don't think the average person playing with AI on his iPhone perceives any danger. Can you just roughly explain what you think the dangers might be?
Yeah, so the danger, really, AI is perhaps more dangerous than, say, mismanaged aircraft design or production maintenance or bad car production, in the sense that it has the potential, however small one may regard that probability, but it is non-trivial. It has the potential of civilizational destruction.
This is just one example of a prediction Asimov made, among many others, including computers and their impact on robotics. Here's an interview from 1982.
All right, speaking of what might happen, though, back here on Earth, the computers have really come into their own in these last few years. What do you see ahead for the computer age? Have we crested on that one as well?
Oh, no. The computer is at the center of everything. The computer is a problem-solving device. It is a technique that makes it possible to do things that would be utterly impossible without it. We couldn't reach the moon without the computer. We require the computer to handle these spaceships that we're making use of. Everything we do in space, we won't be able to do without banks of computers doing thinking faster than we possibly can. And in the same way, the advance of robots depends entirely upon the computer. In fact, the simplest way of defining a robot is as a computerized machine.
Do you see a time where computers at the basic human level in homes and that sort of thing, that everybody will have a computer, will have to have computers in order to exist and make it down here on Earth?
It's not even a matter of having to have it. They'll want to.
It's 1956. George Duvall enters a cocktail party and eventually meets Joseph Engelberger. Duvall is an inventor, while Engelberger was an American physicist, engineer, and entrepreneur. They begin to have a conversation and connect on the science fiction work of Isaac Asimov and his theories on robotics. 2 years previously, Duvall had filed a patent for a general-purpose manipulator and was looking for financial backing. Engelberger was interested in applying flexible machines into factory automation. This conversation led to a plan that would forever change the landscape of industrial manufacturing.
A robot for industry. And this is it, Unimate, a machine that can reach out to 7 feet and perform a multitude of tasks in factory or laboratory as skillfully as a man, but without getting tired. It's controlled by a built-in memory system. You just lead it once through the required motions, and it can then repeat them 24 hours a day, week after week. It can position objects to within 50,000ths of an inch.
In 1961, Engelberger established Unimation Inc. in Danbury, Connecticut. The same year, Unimation released its first commercial industrial robot named Unimate. This robot is the precursor for automated assembly lines around the world today. The Unimate 1900 series became the first mass-produced robotic for factory automation, with the unit being installed at a General Motors plant in Trenton, New Jersey. This plant would later become the most automated automotive plant in the world. Other automotive companies such as BMW, Volvo, Mercedes, and Benz followed suit and began buying robotic arms from Unimation. In 1966, Unimate was introduced globally on the Tonight Show. Unimation later would sign licenses with Nokia and Kawasaki Robotics to establish a market in Eastern Europe and Asia. Unimation revolutionized robotics, however, beginning in 1981, competitors were eroding Unimation's customer base. New electric-driven robots were desired by companies which Unimation didn't provide. The Unimate relies on hydraulics, which were not efficient compared to the electric-driven robots. The biggest indicator of Unimation's downfall was when General Motors began a new partnership with Ford, which provided the electric-driven robots they desired. Sales dropped, and the company was ultimately sold to Westinghouse in 1982. In 2003, Unimate was inducted into the Robot Hall of Fame. Today, industrial robotics is bigger and more affordable than ever. The average person can buy their own robotic arm for as cheap as $7,000, depending on the application. Fanuc is the largest industrial robotics manufacturer with over 500,000 robots around the world. The application of the robotic arm has also expanded into the service industry, dental industry, and medical industry. The future of manufacturing is very bright, with new technology being developed at universities around the world. One such technology is cold spray additive manufacturing. This technology uses a gun to spray fine metallic powder at ultrasonic speeds onto a substrate where the energy from the collision of the particles establishes a metallic bond. Like the metal 3D printers currently available in the market, cold spray additive manufacturing would increase efficiency, lower cost of operation, lower the amount of waste produced, and expand the applications of industrial robotics. Thank you for watching.